There we go. We all set?
All right.
I see the ticker. Welcome.
uh, excellent. Yeah, this is my first streamer organization one. So
you hit the live button. You're a pro now.
Yeah, you are now a professional podcaster or recorder or streamer or whatever.
There we go. I'm a professional webinar holder.
Yeah, you can put streamer on your resume.
Yeah. Now you got to get some neon stuff in the background. You got to do like your hair and pigtails.
It escalates quickly.
Yeah.
Oh, I'd like that. How about that? Pigtail. Let's see. Who do we have? We got people. I'm trying to figure out if we got people who have joined us.
I don't see the counter. If anyone's here, just say hello in the chat. That's a good way to kick it off. So there's my hello and yeah, if anyone's watching live, hello. There's Alex. See, we got people here.
Thanks, Alex. Sean.
Thanks, everyone. Oh, Sean, who let that guy in?
Excellent. Well, thank you all. You all are here with my inaugural StreamYard webinar organization. So be kind. And I know that we are going to give it probably just another minute or so, and then we'll go ahead and kick off. Give another minute or so for people to join. How about that? You okay with that, Justin and Tim?
I'm totally fine with it. Well, we can talk about whatever. I was just going to say that the one thing, if I've learned anything about streaming for now the last 5-ish years, is everyone loves disasters on streams. Like that, everyone always wanted more disasters. So like we love it when things don't work. And
it's the opposite of production rollout or like a talk, right? Like a talk, like no one wants a dramatic production rollout, but like a little bit of disaster in a stream is great because then you get to see how people really are instead of the people that they want to present. It's
see how we react to when cats jump onto our desk or dogs bark in the background, kind of thing.
Yeah, cats on the desk is a thing which you miss in the early things. My cat, like my desk is by the window, aka the cat TV. So my cat will watch TV. You'll just see a cat tail just come right across the screen.
Yeah.
I love it. I love it. Yeah, my dog was just barking at something. We actually had a bear. A raccoon got into our trash that is behind a fence last night. So yeah,
it's interesting that it could be one or the other. Where do you live? Where it could be a bear or a raccoon?
I live in the mountains of Colorado.
Okay, yeah.
Yeah. So my trash was all over. I'm pretty sure it wasn't a human, but whatever animal pulled a slat off the wooden fence. So yeah, they were quite intent on hitting my trash. So
the slat off the wooden fence makes me think bear because raccoons will just climb fences.
Yeah. Well, if it's a bear, it's pretty small bear. So
could be a baby.
Yeah, it could be a baby. Okay, anyway, we're at 10:03. I think let's go ahead and jump and do some introductions. Welcome. Thank you, everybody who put their name in the chat. As we mentioned to people who just joined, jump in the chat, say hello if you're here, because this is my first webinar via StreamYard. So as Neil said, I'm becoming a pro streamer. We'll see how that goes. I'm Kim McMahon. I am the head of marketing at Sedero. And I have put together Justin, Tim, and I plan this webinar to talk about Kubernetes efficiency. So we hope you enjoy it. Justin and Tim, go ahead and jump in with your intro. Tell people who you are and why we care.
I'm Justin Garrison. I'm head of product at Sedero. I come from working with and in the cloud for quite a while. I was at Amazon for 4 years before this, which is when I learned how much cost mattered to a lot of people, including Amazon. So.
I'm Tim Banks. I'm a customer solutions architect at Kalent. I also did a stint at Amazon, so I do also know why people care about cost and why it doesn't have to be the way it is. If you see how the sausage is made for a while, you get an idea of how to make something a little bit better sometimes, but yeah, no, long and unglamorous background in tech, and I'm here to share what little bits of knowledge I have.
Well, you both have a lot of bits of knowledge, and you both have had a lot of experience, and you're quite vocal in a lovely way about efficiency and saving money on cloud costs, and that's why we put this together. And we did do some chatting as we were prepping the webinar. Tim, I love the comment you said when you said it's not 2008 anymore. But let's kick off and give people a little bit of why you're so passionate about this topic.
Yeah, so I think it's real interesting. I predate the cloud, as if you couldn't tell by the gray in the beard, and I do remember what the cloud promised us when it first came around. It's like, it's going to be real fast, infinite resources. You're only going to pay for what you use, so it's going to be real cheap, and all these things that that the cloud to some extent delivered on, but in a lot of ways it didn't. And one of the ways in which it primarily didn't deliver is cheap. So it's like, it's cheap if you only use a little, right? But large organizations didn't go in there and use a little, or customers that went in there and became successful didn't go in there and use a little. And there are a lot of ways in which it added up. And then folks found themselves spending their annual, data center budget, or their data center budget for 3, 4, 5 years within a year. And in a lot of ways, it was just because of the nature of utility billing, but also because they didn't know what they had, like S3 bucket just out there. We would go in there and folks would have entire, like, oh, we haven't, 5 different copies of our infrastructure in here because they're all dev, and things like that. So like people kind of, a thing I've said in the past is the cloud has made us reckless, and it has. We just don't think about these things because there was always more compute. There's always more storage. There's always more this. I can just go interact with it. So like, why do I have to be careful with it?
What I always hate doing is once a year, I go through a bunch of my files and I clean them up because I start running out of space. Even more so in the year 2025 with AI models that are 80 gigs or whatever. But like, it was just a thing that like I had a limit of my hard drive space, and my options were I can go buy a new hard drive, or I can just figure out like, oh, let me go do the little graph that says you're using a bunch of space here, go move that somewhere. And in that responsibility of I have a limit and I need to stay under that limit was annoying, but it would help me with things. And just people don't do that anymore. People don't have those small limits anymore. They just let the bill keep growing.
Yeah. It's like, imagine if we treated our fridges or our garages or houses or whatever, like we treat like, our cloud infrastructure. We would all have gigantic expensive houses, and maybe some of us do have gigantic expensive houses. And if you do, like, have tip of the cap, but like, for the most part, like we treat our infrastructure uniquely and in a way that shows that we really just don't be thinking about like what we should be doing with it. Which is like, oh, it's just, let's make something new. Let's make something, like we get caught up in this notion that in order to move fast, you can't pare anything back, which is completely opposite. You ever seen a heavy, fast car? Like it just, they do exist, but they're extremely expensive. Most of the time, when you think of agility, you think of light, you think of easy to move, you think of maneuverable, you think of something that is efficient, right? Not something that is bloated. And we have a lot of bloat in what we do. Like, and it's I don't want to just restrict it to what we do in cloud. Like, if you want to talk about like one of my favorite punching bags when we talk about cloud is Kubernetes, because I remember what Kubernetes was like when it started. I remember what the promise of Kubernetes was when it's supposed to be super light, stateless, little things pop up there just to manage your Docker containers. And now we have what we have now.
Yeah. Speaking of bloated.
Yeah, it is very much so.
And I kind of view you two as some of the initial voices, some of the voices early on that were kind of alerting people to this bloat, for lack of a better word, this bloat that people had in cloud. But and now I see a lot of people talking about it. So what do you think has changed in the last, I guess, couple years where it's now become more of a front and center conversation, that people finally realize they retire their bills, or do we need to control more costs in our infrastructure? What do you think is really making that change to where people are talking about it? And
so a lot of people exchanged money for time or knowledge, right? And I say this when we talk about Kubernetes. Kubernetes started off complicated, right? It was not easy. Like, it would make things easier if you really knew, but it was not easy. And it didn't get easier. It got more difficult, more complicated as you added more parts to it, more things to it. More people but wanted to do more things with it. And so you had to make it more complicated. And a lot of it, to some extent, was resilience and expanding it beyond what it was originally supposed to be doing, right? And making it work in all these different places and all these different ways. It became very complicated, right? And instead of decomplicating it, right, we're like, well, what if we paid someone to put a layer on top of this to make it easier to manage, right? Well, sure. Okay. Yeah, that's fine. You had managed this and managed that. All the cloud providers now have their managed control plane for Kubernetes, which costs money. You don't really think about how that works. You've got, we pay for things to make things easier to deploy on, like Terraform Pro or GitHub Actions and all these other things that we have to make things easier and more efficient for us, so to speak. But we're exchanging money for those things, right? Because it was easier, right? And so as you look at the vendor relations we have to make this thing easier, you look at the providers and you look at the number of things we're having Kubernetes do, we're doing on Kubernetes, and just what it does and how big it is and how expansive it is versus what it started off as, in 2015. It is huge and it is very inefficient. It does more things than we used to do, and we don't pare it down like who. And maybe some folks remember, who here ever remembers compiling a custom Linux kernel, right? And a custom Linux kernel has, it used to be back in the day because you had to do it if you wanted anything to work. And then a lot of folks did it because it didn't need to be as big as it needed to be, right? You didn't have to have tape backup drivers. You didn't have to have video drivers for stuff you didn't use. You didn't have to have the capability. You didn't have to load 3.5 floppy disk drivers. There's a lot of things you didn't. So you customized, you compiled a kernel to make it more efficient. We don't do that anymore. We don't really, develop a Kubernetes for specifically the things that we need, right? It's still this big bloated thing. And there's probably space for that. There's probably room for that. But in the meantime, we don't look at our own organizational process or infrastructure or anything like that and compile an infrastructure for the things we needed to do only, because we're taking away development cycles. We're not focusing on the product. So we kick that efficiency can down the road, and it costs a lot of money when we do that.
I've never compiled as many kernels in my life as I have in the last year and a half working at Sidero, because Talos builds a kernel from scratch. And I was just like, every time I'm building it to test things, it's fascinating because we talk about bloat and all this stuff. And I'm like, oh yeah, we strip out a bunch of stuff. And it's just like, yeah, no, we have a set of, this is what we think the OS should do when you're running Kubernetes. That's a sidetrack of, I completely agree with you that people aren't looking at how to reduce this stuff because it's not an emergency and it's not rewarded, right? Like inside of organizations, no one's ever said good job running servers, right? Like that's the age-old sysadmin. Like no one ever congratulated you for running servers that year. And I know plenty of people that have saved their companies, millions and millions of dollars on infrastructure reduction that are like, hey, get it, good job. And you get an email, right? That's it. Like it's like, here you go, congratulations on doing the thing. That's your job. Now get back to work, kind of thing. And like, but if you are the developer and you create value, if you make money for the company, then you get spot bonuses and promotions. And it's just like this weird way of like saving money is never as glamorous as making money.
It's so funny because that reversed in 2020 when a lot of folks had to like, oh my gosh, we need to reduce our costs because everything is shut down, et cetera, et cetera. And I was working for AWS partners at the time, and then I went to work for Duckbill Group at the time, and it was like, yeah, people were giving a lot of money to consultants to tell them how to save money because they lacked the operational expertise and the infrastructural expertise to do so, because it had never been something they had ever considered. Mm-hmm. And even when it comes down to things like, oh, we're going to sign a new contract, right? For AWS. When back in the old days, you used to have to be able to predict cost and usage and what you were going to do whenever you wanted to provision anything new in a data center, right? So, 9 times out of 10, there was a spreadsheet and you had to go through and be like, oh, how much memory is it going to use? How much disk is it going to use? How much CPU is it going to use? How many visitors do you think it's going to have? What do you think its expected growth is over the next blah, blah, blah? You had to do all these calculations before they're going to let you have resources, right? Yeah. That expertise, that knowledge went away when the cloud came around. And so when people go to do contracts like, private pricing agreements or enterprise discount programs or any kind of committed spend, they don't know how to calculate this thing.
Mm-hmm.
And so they end up relying on AWS to tell them what they think it's going to grow and committing to this thing without really checking it, or pay people like me to come in there and be like, this is what it actually is going to look like, blah, 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 right? People have not given thought to how it's going to work, how it's going to look like when things go into production, right? You look at like the advent of kind of like chaos engineering, right? It's like, what could go wrong? Like that's one aspect of it, right? What could possibly go wrong? What haven't we documented? What haven't we thought about how it can break? But we haven't thought about how it can grow.
I mean, isn't that FinOps? I feel like that like it came from this sort of world of like, we used to do budgets, now we do FinOps.
Like FinOps, it's really interesting because FinOps is supposed to integrate financial concern into the development process, like DevOps, et cetera, right? But FinOps, by and large, has just become people shuffling around Kubernetes containers. Like nine times out of 10, if you look at a FinOps vendor, right, we're going to shuffle around a Kubernetes container to either Spot, or we're going to shuffle it around to like this lower cost thing, right? And using machine learning to do that. Whereas FinOps is supposed to be kind of reactive first, then proactive, where you're going to look at your infrastructure. Like truly in FinOps, you would take someone who's really smart with, like the economic impact of infrastructure, who's going to look at your proposed architecture infrastructure. You're like, this is going to be a little more expensive than it needs to be. Maybe you can use this and this and this. Let me look at your code. All right. Does this have to run every so often? Does this there's no sleep here. You realize how much CPU that's going to use, right? What can this be triggered? I know you want to run this on a Lambda. How often do you think it's going to get invoked? Oh, well, that's a lot of implications. Have we thought about running a container? Like these are the things that's going to be like, if it was just like you would do like SecOps, like security folks are supposed to go in there and ask you questions about how you think, how you developed to look for potential vulnerabilities in your code, in your process, and in your infrastructure before it's developed. FinOps is too reactive right now. It is not at the beginning, and that's where you save all your money.
If it's at the beginning, it'd just be a budget. We would just go back to the boring words.
Yeah, but at the beginning is you save all your money. You save almost all your money on the whiteboard, never the keyboard. And so these are the considerations people have to have.
Yeah. So what's interesting here, Tim and Justin, you're talking about like the complication of the infrastructure and hiring a consultant to help you figure out how to save money. I mean, was it always that way, so did people? I guess the question is, did the infrastructure get so complicated that your infrastructure engineers just couldn't keep up with how to best and most cost effectively manage it, or did that knowledge just go away through simpler tools?
So one of the things that happened with the cloud is they were telling leaders, like, you don't have to have backup administrators anymore. You don't have to have VMware admins anymore. You don't have to have hardware administrators anymore. And those jobs went away, right? Everybody was developers now, right? And that's, they told you, oh, even people to this day still think that DevOps means that developers are doing ops. And that's not what it is, right? But that's what it enabled. Like, oh, I could just go programmatically provision some infrastructure and I don't have to think about it because AWS or Google or Microsoft is going to do that for me, right? And that can work. Like, there's organizations now that still don't have operations groups, and I don't, I would love to be their AWS account rep because I will make money hand over fist, but still, like, they do it. So to some extent that expertise went away, but a lot of times too, like, it still changes, like, because you changed how the platform is, there's a whole bunch of different levers to choose from and how you do this, right? But I think what is really interesting is that, and when we go back to saying it's not 2008 anymore, right? A lot of the reasons why people went to cloud provider, as far as programmatic access or developer experience when you're provisioning hardware and interacting with hardware, you can do that now on hardware you own, right? You don't have to actually pay a cloud provider to get that experience. But the main problem that you have with people going back into owning hardware and running in data centers is that if you were someone who was born in the cloud, you don't have that expertise, right? And so a lot of that expertise is relegated to enterprises who either never went into the cloud or never went fully into the cloud. They still maintain that expertise. And so like, well, how do you learn how to run a data center? You know what I mean? Like, how do you learn how to operate a rack of servers? And that's hard. That is a challenge, right? But you can still bridge that gap. You don't actually have to be in charge of running the servers. You know, you don't have to polish fiber optic cables anymore. Well, I don't, but you know, you can still get that hardware delivered. Like there's companies like Oxide. Like I love. Gosh, I love it. You know, you just buy a rack. That's essentially your own private cloud server that you can, you know, everything interact. Here's your API endpoints and like go plug it in somewhere. You can go to Equinix and like, hey, you plug it in. They're going to charge you for electric, going to charge you for power cooling, and then if something goes wrong, they'll send a person out there to like actually work on that kind of thing for you. Like so, you can. There are ways that you can run in a more cost efficient method by owning your hardware and still maintain the experience, but they're not really widely known.
And I think one of the practices that we've really lost is that finding the tipping points when something doesn't make economic or just like maintenance sense, right? Like Lambdas are great to get started if you're running something occasionally. And then I know plenty of folks that spend way more on Lambda than they ever would on a single EC2 instance, just sitting there doing the work. And at some point, like all these tipping points become, when is Kubernetes worth it? When is Kubernetes not worth it anymore? And finding out those points of like, this costs this much money for this amount of work, and people just get stuck in no, Lambda's cheaper, so I have to always run. I'm like, well, like, are you sure? Like, have you done the math? Like, there's a chart that the lines cross somewhere. And
there is. It is funny. So I've actually run this calculation. It's like, okay, you have whatever your Lambda CPU time is, and then you have your Lambda invocation time, right? Or invocation nodes. So whenever that CPU time, whenever that invocation number reaches X point, right? Now the CPU time just of a container is less than the CPU time plus the invocation cost of a Lambda, right? And then like, oh, we'll just make the Lambda run longer. It'll just run for 10 hours. And I'm like, then why not just have a container?
Yeah, that's very expensive.
you know, like, but it comes to what are people used to using, and it goes back to like the combination. Like, okay, if I want to use containers, like how do I orchestrate them? Do I use Kubernetes for 1, 2, 3 containers? I mean, is that overkill? And yes, no, that is overkill, and that's why people end up using Lambda. Like, but there are so many other ways to launch a container or orchestrate a container that are less than that require less than that, or God forbid, you just stand up an EC2 instance, you know. But you know, we get kind of like stuck in our ways, like, you know, kind of a sunken cost, you know, fallacy. It was like, well, this is the way we've done it. Changing is hard, and it is hard. Don't get me wrong. You know, to say like, we were going to take this major infrastructural thing and we're going to switch it to something else is a huge undertaking.
Yeah.
Right. But you don't have to do everything. You don't have to do everything all at once, but you can certainly do pieces of that. You can move certain aspects, you know, greenfield, just play around with it. Like it's interesting how a lot of people have done pivot to like inference and training AI and stuff like that, training AI models, and they go right in their cloud provider with a whole new team. And like, yeah, we're just going to stand this up. We're going to use these services, blah, blah, blah. And that's fine to like do some development, but once they go into production, they're doing it all the time. And it's like, oh, you just like to set money on fire. That's all. Because the owning of infrastructure for these workloads has been around for a while. There are places you can that you can rent now. Yeah, but like if it's a green field, if it's a new project, if it's something we're going to do brand new, that is the perfect time to look at doing it somewhere else other than in your own cloud provider.
Yes. So, go ahead, Justin. Do you have something you want to add? Because I got to
like, do you think? I mean, the other thing that the cloud promised us was speed, right? They're like, oh, you can get started faster and just deploy some things. And one of the promises of Kubernetes was portability. of you can move this somewhere else and keep the same interface. You can run Kubernetes wherever, so it'll always be the same. Your workload's portable.
Oh, the Java promise.
Yeah, the job, exactly. The write once, run anywhere promise. Do you think it's lived up to that? Do you think that's reality for people?
It is still possible, and I have seen it. And there are people, if you do Kubernetes well, you can do it anywhere, right? And that is a huge asterisk. It's a huge asterisk, right? Because a lot of people and I'm talking, when you do it well, it's like, okay, we don't have anything that is specifically proprietary to this vendor or that vendor or this cloud provider, that cloud provider, or we have enough automation where we can just switch it by changing variables or whatever. We don't have data that has to go with it, which is the big thing. Because in the end, data is the only thing with gravity. You know what I'm saying? Like computer's agnostic. I can take compute and run it on this or this or this or this or this. It's all the same processors, more or less, right? But anything that requires me to go hit data somewhere, now where's that data live? Where's it going to? Now I have to be close to that data because then you lose speed. So the more that you take your workloads that don't require stateful data somewhere, right? And optimize those for portability, the better off you are, right? And then you have a great example is if I have to generate batch data, like training a model or something like that, do I need to be close to that data? Maybe, right? But if it's not urgent, I can train that data anywhere, right? I can hit it off an S3 bucket, store it here, put it like that, and then go through it, and then train off it for X amount of time, and then deliver an archive or an artifact rather somewhere, right? Mm-hmm. It's not the most efficient in the world, but you're going to look at how much is my CPU time versus how much does it cost for data egress.
That's the thing that I think is surprising to a lot of people. Like the cloud business model definitely knows that there's gravity to data, and they don't let you get the data back unless you're paying for it, right? Like they'll let you send everything in and only
to get in, cost to leave.
Yeah. For the longest time, I was saying that Disney Animation had the best cloud economic model because all of our data was created in-house where the artists were, and we would render some things in the cloud, but we would send them, tens, hundreds of gigs of data, and then we'd pull back one image, 2K image. And we're like, cool, our egress fees are almost nothing because we render it all there, and then we just delete the data. We're like, we don't actually care. We have a copy of it.
Yeah. And that's where I think a lot of your stuff with machine learning models and stuff like that can come in. It's if you want to run your LLM in your own hardware, right? But you want to train it on the cloud, perfect use case, right? But also too, there's the main sticking point that you have even with running your own hardware is that the one thing that I don't have, infinite of is hard drive space. You're never going to beat storage costs for objects in the cloud. You're never going to do it, right? But
assuming you can use objects, right? That's a big if asterisk there of a lot of if you're doing NFS, if you're doing some of that other stuff is super expensive. Object storage is the absolute dirt cheapest, and it's great.
Yeah. So I would never have a tape backup. I would back up everything to S3. Because why? Because I'm sending it a lot of data, and maybe I need to pull some out one day, right?
So this is flowing directly kind of into the question that we have in the chat from Chrysalis. I don't know if I said your name right. At what point would you recommend someone switch to a private cloud with their own hardware? For example, using SUSE Harvester to provide a similar experience. So the question's kind of feeding into what you're talking about.
So I think it's real interesting, right? There is, when you start to look at your bills, right, and they're starting to hurt, right? The first thing I would say that you want to look at is before you do any kind of committed spend contract with your provider, and that includes reserving instances, right? Look and see how much it would cost to own that hardware, right? And the number is going to be less always, right? For me to buy equivalent hardware, even if I'm buying it in a couple different places for redundancy or whatever, right? Call up call up a Dell salesman or HP salesman or whatever salesperson. They're going to be happy to like give you a good pricing like that. But that's not the whole thing, right? It's like, okay, now where do we run it? How much is that going to cost? You can do a cost study, right, on those things, and it's not a bad investment of time, because that is something you can refresh numbers on at any point, right? It's like, okay, we have it's a great way. My project has tagging. We know what our costs are for this. We reserved this instances. These have been at bill so far. We're going to reserve this much for this. Okay, so it'll cost us $300,000 this year, right? Okay. We go and we buy equivalent hardware. We got a quote from HP for this much hardware. It's going to cost this much. We got a quote from Equinix. It's going to say, hey, it's going to be this much for however long. We know approximately how much data we're sending out. We know how much approximately that would cost us here. So, and you can run those numbers in a spreadsheet. Honestly, if you don't know, if you have someone in finance, that's who I would ask, because they can tell you how to run those numbers almost always. If you don't have someone in finance, you may want to pay for a cost study to do that, depending on what your budgets are. Depending if it's an enterprise person, they're absolutely going to do that, right? You can even go out and get bids on it for folks to have contracts to do those kinds of things, right? But if you're talking about just regular in-house, right? The other thing you're going to have to consider is like, what is my engineering cost to do this? Right? Because if you are hardwired essentially for working in the cloud, do you have to do rewrites? Do you have to do, retooling and rewriting your code and stuff like that? So that's a factor. That's something you have to factor in as well. So there's no easy point to say this is the actual point we should do it. But the time you should look at it is before you do any committed costs to your cloud provider. Like I said, PPA, reserved instances, EDP, anything like that. It's a good time to go look at that.
I used to always tell people that there's nothing cheaper than running on the desktop or laptop on your desk. Like this, the absolute cheapest way you can run anything is the compute you already own. And you're just like, okay, but what are the trade-offs? And then you look at, okay, how much do I need people from around the world to see this? All right, should I use the CDN? Like I always start from what's at your desk that you could use today to run that service. How would you run it? Okay, now let's look at where the trade-offs don't make sense anymore. And especially if you're starting small, right? If you're an enterprise, it's a different story. And you're like, I already have, 87 different Kubernetes clusters in 3 different cloud providers and all these other subscriptions, stuff like that. But for like a developer, for a small project, for a small team or something, like how do you start the smallest and then work your way up to where are the trade-offs necessary for, hey, actually, I need this to be redundant in 2 locations. Okay. How do you need redundant power, redundant networking? What do you actually trade-offs? If one of those goes down, is your business gone? Or is it costing you money? What is the actual impact of that outage? Because people say like, I need all of the 9s to be highly available. I'm like, do you? Like, do you really? Like, is that actually, critical to you? I used to work at a university, and in the top most important thing to them was the front page website, which for some reason we ran. I mean, this was back in early 2000. We ran it ourselves on-prem from our data center. Like the website cannot go down. And I'm like, does it make us money? Is it actually like the students are already here? They're paying tuition. Like they don't go to the main page. Like it's not a thing for them to say like, oh my gosh, the main website's down. I guess I shouldn't go to class. I'm like, no, like actually, like we still like all the money's still here. Like, is this okay? Let's have 2 9s available. Like what's 2.5? I don't know. But figure that out for what are the actual trade-offs for what you're building. And then if you want, Harvester is one piece of the story, just like VMware or whatever, right? Like a lot of times people focus on where's the compute, because that's the thing doing the work. But the networking layers, the storage layers, all that other stuff is important. That you're like, do I want all of my storage in a Harvester system, or do I need something like a NetApp or some other external thing that gives me better performance, better cost per dollar for storage, whatever? Like those are all important things to consider.
Yeah.
Well, and I think well, I was going to say, if we bring this up a little bit, because I don't know who's listening or who's on the audience. Like, and so for me, like, I have no idea what I would need in my on-prem environment. Like if like it's sort of whatever. So if we bring it up from a business perspective, like, the redundancy, as you were mentioning, Justin, like what's that bullet list of the person who's running the business says, this is what I need in my compute environment. And then how can they go to find out, like, what does that really mean in terms of what does that infrastructure engineer that I'm going to need to have on site look like, or what's the other hardware, networking, storage, et cetera. So
for me, this goes back to that notion of like, take a project and put it in there one time. Like, if you were to say like, hey, we just want to see what it's going to look like for us to run in a data center, right? Cool. Take a small subset. We want to run this little project in there and go do it as greenfield. Like you would approach anything greenfield. Okay, we're going to go in there. It's like, all right, design the architecture. It's going to need storage. It's going to need network. It's going to need backup. It's going to need compute. It's going to need, these caching layers, blah, 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 blah. Okay, great. Now, if we have that, it needs to be in 2 locations. All right, great. What does storage look like? Does it need block store? Does it need object store? Does it need, common file system, et cetera, et cetera? And those are different solutions for each. Now you can use some solutions that do all of them, and optimize for the other, but so it is literally like those pieces are going to depend on what you're doing. So take something that's an example of what you're doing, and then you'll figure out what pieces you need. And along the way too, like it's a great way to learn, like, oh, how much networking expertise do we need or do we not have, right? If you have spent any time configuring really your security groups and everything like that for good secure access for your cloud, you've given thought to some of the network aspects, right? Subrange, subnets, all the IP ranges and stuff like that. And enterprise, you probably have network folks, right? But if you're small, you probably don't. And so you're going to have to figure out how to learn these things. Now, there are still like the network hardware providers are aware of this, and they have made a lot of things a lot easier for folks who have never worked on network hardware to try and configure these things in ways that are compatible with a lot of ways you've done it. You can, a lot of your automated systems now or infrastructure as code systems can also do network as well. Ones that aren't cloud specific, obviously, but so there are ways to go from one to the other to get a similar experience, but it does require, it's not like there's no knowledge gap, because there is going to be, you do have to know what you don't know.
And I mean, every one of these companies will teach you for free on how to spend more money with them. They all, hey, if you're going to spend money with us, we will absolutely spend time to teach you what gaps you have and to teach you how to be successful. They want you to succeed too, because they want you to spend money next year too. And that's totally reasonable to say like, oh, hey, I don't know what I don't know. Where should I start with some of this stuff? And to your point, Tim, like starting with the easy things to move, like, oh, I have a stateless web service. I want it to run on-prem and see what it does. I'm like, all right, you're going to learn a bunch of stuff that you didn't know that was taken care of for you by a different team, or some defaults in the settings where you were running, whatever it might be, right? In Kubernetes, the flavors of it where it's running, like they have some differences on, oh, this was the AWS, the IAM credentials and ECR plugins and all that other stuff. Like it was doing stuff for me that I didn't know I had to maintain if I'm not running the EKS cluster. And so being able to understand what the gaps are and what you need to be responsible for is important, and you just got to do it slowly.
Yeah. Yeah. Thank you for your comment, Robert. Yeah. Interesting. And then Jack has a question. Any top tips for getting cloud storage to on-prem compute? Downtime is cheap. It's data redundancy that's expensive.
So cloud storage, again, it's going to be depending on what type of data it is. Like if we're talking object data, you kind of throw it anywhere, literally. But I think where we come in, it's like, is this data for like a database? Is this data for a file server? Or is this backup data? Is this kind of like static data that just going to serve assets and things like that, right? When you're talking to getting it from, so if you're talking about like cloud storage to on-prem compute, like for example, I've got assets in S3, right, that I need to get that my on-prem compute needs to run calculations on, or I'm serving things from, like, all the compute for this website is done here, but the actual static assets are in S3 or CDN, which is a very, very common thing, right? You can, there are ways you can either pull it in directly through Direct Connect. You can cache it somewhere, depending on what needs to be done. You can just have a call to it directly and have like, oh, all the compute's done here, server-side rendering. And then it's like, oh, but like when you pull the page in your browser, it comes from a CDN or it comes from S3, right? So it kind of, the principal or architect answer of it depends actually fits here. But I do think that there are some other methods when you're talking about like the data redundancy that's expensive, right? There is nothing wrong with keeping your backup data in the cloud. I actually think even if you're running in a data center, it's a brilliant way to do it. Again, like we mentioned before, because no one wants tape backups anymore, right? But like having like I run my you run backups and you throw them in S3 Glacier or something like that. Perfect. Especially if downtime that's down. If you're not super concerned about the downtime, it's not like it takes long to get stuff out of S3 specifically, but it's like, hey, we need to pull these, few gigs, couple terabytes of backups into here so we can restore them. Okay, well, cool. Like you're only going to pay for it when you restore it. So the storage is going to be ridiculously cheap. The upload is going to be it's not going to cost you anything. So I think that's a good way to incorporate. Like when people talk about like a hybrid infrastructure, I think that's actually a very valid use case. Like I just want to throw all my static data, my archival data, stuff that I'm not going to touch very much. I'm going to throw that into cloud storage because it's cheap and I don't have to worry about it.
And if the data's not cold, if it's not a backup, like if it's hot data, only pulling the data you need is pretty important. There's plenty of like, if you're doing NFS, there's like pull through NFS caches, right? That's like, hey, on demand, fetch only the things I need and then store them locally until they time out kind of thing. Like that stuff exists for a reason, because it's like, how do we make it fast locally, but also minimize the egress costs? So all of those things are options. And your first time fetching the data is going to be like, oh, this is NFS server is really slow. I'm like, well, yeah, it's pulling it for the first time. Like, just give it a minute. Next pull is going to be fast, right? And if you're doing that over and over again, it's going to be easier, but it's not cheap. It's storage is that like I said, the economic model of the cloud is like, don't ever give you the data back unless you pay for it.
Yeah, and to be fair, a lot of the storage appliances are aware of these types of architectures and they support them pretty readily, pretty easily with the backups or pull through cache. And someone said, okay, so. The question that just popped up that's relevant to this too. Someone's asking, is it safe to keep backup in cloud? We need to follow GDPR. Sure, as long as it's regional, right? If my stuff is in Ireland, my backup better be in Ireland, right? If my stuff is in, I have this in this region specifically, then I have to back up to that region. And you can specify those things, right? But if, I would not throw everything into your US, your US East 1 bucket. If you live in the EU and have to follow GDPR.
The amount of regional cloud providers that have been popping up is, or have been around and I didn't know about them, right, is actually really interesting, because almost all of them are there to follow those regulations. It's like, this is a requirement. If you do business in this country, you need to go to one of these 2 or 3 smaller regional providers, and that exists. Again, it's like things you don't know, and maybe you can't, for legal reasons, keep everything in an Amazon S3 bucket, right? You're gonna have to go to somewhere else that someone else can have a compliant S3 bucket.
Excellent. Great questions. So let's move it to the people that are relying on this infrastructure. Your developers who are building your applications, building your company's products and solutions. How are they gonna? Are they gonna get worried? Do you need to worry about them being worried because you're switching up your infrastructure, or how do you calm?
I'm gonna be real honest. Like if you are a company that utilizes like the principles of platform engineering and you have built developer platforms, they should never know the difference. It would be the only, it's like if all of your dev goes in AWS, it goes in AWS, bam. If production goes to a data center, that should be maybe their only level of awareness of it, that it goes to a different location. But like, it shouldn't matter, right? Now, if your developers are touching the hardware directly, like, or the infrastructure directly, like my developers are writing Terraform, or my developers are writing CloudFormation or CDK, then yes, they're going to have some level of awareness and some level of retraining. Especially when it comes to like architecture and new products, right? We're developing this new thing. Well, we can't actually use DynamoDB, things like that. So to some extent they will be aware, but in other ways they probably don't need to be. So it's situational. But I think for day to day, they probably don't need to. But when it comes to product development and product architecture, absolutely.
Okay.
I almost take the opposite approach where I say that migrations are always happening. Every company I've ever worked for in the almost 30 years now of working random places, there's been at least one migration that's going on, and people are just kind of used to, like, there's always something in flux of, like, we have the old wiki and the new wiki, and the old platform and the new platform, and the old version of Java and the new one. And there's always some state of flux in the systems that I'm like, yeah, like I just always lean into that and say, hey, when can I break something? When do I get the opportunity to say that's not going to work anymore? You have to change your application or your practice or your CI/CD. And hopefully I'm going to, you know, as the infrastructure person in that group, was like, say, hey, I'm going to help you get there. I'm going to show you an example of how to transition it, because they're all going to copy and paste the old Jenkins structure to the new Jenkins structure, right? Like that's happened in my career. And like, hey, we're moving to GitHub Actions. Okay, cool. Like, how do I translate this Jenkins file to GitHub Actions YAML? Like, oh, okay, we'll figure it out, you know, what you need, and give you some examples. But being able to tell them, like, this doesn't work anymore, and being able to, like, pay down that tech debt and just delete it. So, like, oh, when this thing goes away, I'm done with that, and I don't have to worry about that piece anymore. That was a big security nightmare, or a lot of upkeep, or just incorrectly designed for what it was intended to be used for. I love leaning into that and saying, like, we always are migrating, so let's figure out the ones that are going to be useful for us and useful for them.
Excellent. Maurice has a question in here. When's he going to meet limitations? He has huge nodes in their data center to optimize, and he wants to optimize their footprint and cost.
And my question, as someone who works with, as cloud economist and as an old infrastructure nerd, is like, why do you need bigger, faster nodes? Like, what is it that you're actually doing that requires bigger, faster nodes versus more nodes? And not saying that you can't justify it, but just there's a lot of folks that we need faster because faster exists. And the question is, to what end, right? Now, a great example that you'll see is people like, oh, well, it's like when we're doing building of something, like the build takes, X amount of time. And if there's more CPU, maybe it takes less time, or this batch job takes this amount, like that, right? And I always ask this, like, okay, well, what are we putting in it? Like, how many cores does it actually need? And how do you get those cores, right? Does it need bigger, faster nodes, or does it just need more cheap nodes? Or does it need access to these to the CPU that maybe is not being utilized otherwise? The old adage of thin provisioning. It's like, you have access to this number of cores, but you're not really using those cores. But if you really, really need those cores, we can give them to you, right? So the thing is, yes, you will meet limitations. There is a finite amount of, like, as you said, space and power in a data center, right? So you will have to understand, like, what your maximum capacity is, right? And operate within that capacity. It's interesting because, like, there are limitations within your AWS account. Like, you have API call limits, you have rate limits, you have all these other limits that you hit. What is not a limitation in AWS account is usually storage, and you can provision more CPU. And so, like I said, if it is a case where you absolutely need more CPU and you have hit the maximum that you can in a data center, it's probably not the right fit, right? If it's not predictable, right? Now, if you have predictable gains and predictable increases in that, great, order ahead of it. I'll give you a great example. This is Blue Sky, right? Blue Sky, if you're not familiar with the social media website and service, right? They run on hardware, right? They run on not in the cloud. They run on hardware they own, and they would post about, hey, we're going in here this weekend and we're racking and stacking a bunch of new servers and putting them up there ahead of demand, and they were growing by millions of users a day, right? And they were adding in that hardware to as it needed. Was it the smoothest ride for the user experience? No. Like, sometimes it was slow, right? I don't know any service that can grow that fast regardless of where they're hosted, that's not going to have some problems, but they handle it beautifully with a small team in data centers, right? But they were provisioning ahead. They were like, we're going to need this. We know this is our growth hockey stick. We need to buy more of them. And then we're going to get in there and put them in there. But in the meantime, they were very smart about how they provision stuff. They were very smart about how they utilize CPU across there and storage and RAM. So there is planning that has to go with it. But again, like, to your question, Maurice, if you know it's going to exceed the limitations that you have because you can calculate these things in the data center, it may not be the right fit, and that's okay, right? There are some things that you probably might need to do in the cloud, or expand in the cloud, right, and then migrate to the data center after you provision, right? You don't have to, because something started in the cloud does not mean it has to stay there. Right. And those are architectural concerns. Those are application level programming concerns. But if you're smart about it, you can absolutely do that. And I've seen that time and time again. Folks that optimize for spot are great examples, right? Because if you optimize for spot, you mean I can actually run this code anywhere. Right. Well, cool. Run it in the data center.
One of the things the multi-terabyte nodes sounds like you're running Oracle databases and repurpose them. But like looking at that, like there's limitations you're going to hit no matter what, right? Like if you have power and cooling and space limitations in a data center, you're like, I just need more containers to run here. You're running 1,500 to 2,000 pods per node. You're running more than some people have in their entire cluster on a single node, right? Like Kubernetes maybe isn't the best fit for that because that's just not something that it wasn't intended to support that large of pods on a single node, not necessarily because Kubernetes has those limits, but because Linux has those limits, right? Like you're going to start hitting open file limits. You're going to start getting PIDs that rotate, right? Like you only have 65,000 PIDs and then you start rotating numbers and something's going to use it again. Like once you start hitting those fundamental core limits at a Linux kernel, you have to start thinking about how you're going to break that stuff up and say, okay, and then what's my boundary?
And then too, you're actually losing more in the orchestration, right? The active control plane aspect, managing all those nodes. And one thing that I'd be like, maybe you just run that as a bare image.
Yeah.
Because you think about how much overhead comes to just have a container, right? And how much overhead requires two containers. Like each level container has some overhead, bean count, et cetera, et cetera. Like everything it needs to do to isolate all these containers one from another. That if you're just running one big job on these things, I'm like, maybe I just run it as one big job and not have a bunch of nodes, right? And it isn't something you would see with every other level of virtualization that's ever existed, right? Do I pack a bunch of small things in there and lose a bunch of space, to the packaging, right? Or just run one big thing.
Yeah.
And so in a case like that, maybe you do scale horizontally instead of vertically.
One of my favorite white papers is the Facebook Twine paper, where they talk about their infrastructure, and they found so many more efficiencies by using the single consistent smaller nodes across all their, and they have millions of machines, right? Like it's a ridiculous amount of computers, but they're like, hey, we're just going to standardize on this one size, and everything has to fit in this one size. And we would break up every job by saying, hey, if it couldn't fit here, it needs to be two jobs. You need to break up that service into being two different things to figure out how it's going to run efficiently across the board. Because when they could reuse those nodes for anything they wanted on any job, they gained a lot of efficiencies. I understand that things have changed now, and now they have different, especially in the world of AI, where like we need specific GPUs for things. They're like, hey, we need specialties, but we have different buckets of types of nodes now. We're like, oh, we just have 3 buckets. We have fast disk, we have AI, GPU, and then we have like standard CPU memory. And putting those things into buckets and saying, how is this workload going to run? Where it's going to run the most efficiently? Then you can target. This workload is going to be just more efficient and run faster and be, better utilize the hardware if it's on this type of machine with this configuration. And being able to look at your workloads, again, if you have 2,000 on a single node, like there's probably very little commonality around those things, unless it's just a bunch of, WordPress or website sort of like minimize things. But then you say, okay, what works well for this? How do I make that more efficient to use less resources or compress the memory, all that sort of stuff takes into account at a single Linux kernel.
And I think too, it's really interesting. We've gotten, one of the levels of kind of where we got lost in the sauce is like, you get people who are running they're running a Java VM inside a Kubernetes container that's running inside a VM that's running inside. You know what I'm saying? Like we have all these levels of virtualization, all these layers and layers and layers of abstraction for a thing, and it's like, why do we do that at this point? Like, what do we actually need? What are we actually trying to accomplish here? And maybe we just say like, oh, we actually don't need all these layers. We don't actually need all this abstraction. We don't need to have these layers of complication on top of this just to run, like you said, a WordPress site or some other function. Like, and again, that goes back to like, oh, well, we just run it as a Lambda. Do we run it as a container? That discussion. But like, maybe we pull all the way back to maybe we just run this on the VM, like it's an Omni. Okay, great. Or maybe we just have a disk, a VM image that we run in a hypervisor, or even God forbid we run it on bare hardware.
Hey, so let's close out with this question from Jack. He's wondering if we're still working with Oxide, Justin. So go ahead and share that, and then I'm gonna segue that into my closing. So tell everybody what we're doing with Oxide.
Oxide's been a great partner, giving us resources. The things that originally started with like a suspected bug that Talos didn't run there, and we found some things with the hypervisor, and we were like, oh, this is what we're missing. How would we get this fixed? And they were great at working with us, figuring out how to make that work, and giving us resources to test things. So we've mentioned them in the past. Like it's one of those newer options for how would we get kind of this cloud scale infrastructure that anyone can own. Once you hit a tipping point like that, I forget how much the Oxide racks cost, but when I added up all of the compute and storage and networking you get in an Oxide rack versus what you would have to pay AWS for, I mean, it was not even close. It was just like, oh wow, like how much would now the question is just like, how much does it cost to host this somewhere? Like if I didn't even have a data center, how much would my quote from Equinix be to like, here's a rack, go give me power and networking for it. And it's still way less than doing it in AWS, and gives you a very fast, similar interface for it. So I love working with them. I think what they're doing is really cool, and just kind of rethinking what the hardware stack looks like. But I also was super interested back in the Joyent days when they were doing stuff, at the OS level, and they have a lot of cool ideas about like compute and data co-location, all that stuff. So I've been following what they've been doing. I think they push the limits on some of the stuff, but really just helping people own the stack and be responsible for it in a, you don't have like the delta of knowledge is not that great when you can buy a product that fits really well. Right.
Yeah,
when the use case is there, like I'm not piecing together all the servers and switches and cabling it myself and doing all, you don't need all of the knowledge. You can actually buy a product that gets you a lot of the way there. And I think that's fantastic. So we've been partnering with them on a couple of different things. We have some projects and some events coming up with them. But yeah, it's been a lot of fun, and I really enjoy the like seeing where they're progressing and getting access to their resources and stuff.
Yes, a huge fan of Oxide. Have been from the get-go. Again, like you said, from the Joyent days. Like I've always liked how they approached it, and just absolutely love to see it. And I wish there were more like that.
Yeah, and so they will. So Brian is doing a keynote at TalosCon, October 16th. It's 16th and 17th. Main event is October 17th in Amsterdam. Brian will be there doing a keynote. I'm always interested. Always love hearing him talk. It should be interesting. And then some of the Oxide team will be there as one of our sponsors. So they'll be there talking about their technologies. You can learn more about TalosCon at taloscon.com and register for the event. And then we also going to be doing something with Oxide at KubeCon. More information on that when Travis and I get together and start telling you about what we're going to be doing together at KubeCon. It's I believe the event is going to be Wednesday. And of course, it's going to be fun because it's us and Oxide. So anyway, we're at time. Thank you. Thank you, Tim. Thank you, Justin. Any last comments? You get 10 seconds.
I will just say, like the biggest thing that you can help yourself out with is to think down the road with a project or anything else you're doing. Like think down the road of like, hey, what's this going to cost? What's it going to take me to move? Always just be ready to be able to make a change.
I'd say just take responsibility for what you're putting out there, right? Like knowing what you should be responsible for is a big deciding factor in where you run it, how you run it, what you run it on.
Okay. Thank you so much. Really a lot of fun. Thank you everybody who joined, and hopefully see you at TalusCon. We will also, FYI, we're also going to be at Open Source Summit. Somebody is doing a talk on Talus Linux, and in an air-gapped, I believe an air-gapped is the talk. So yeah, look for some great Talus talks coming up at upcoming events.
Sweet.
Thanks everybody. Bye.
Thank you.